The following video addresses the hazards and correct procedures concerning entry into confined or enclosed spaces. This video contains several sections: Introduction, Confined or Enclosed Space Hazards, Personal Protective Equipment, Testing Procedures, Ventilation and Inerting Procedures, Emergency and Rescue Procedures, and Conclusion. Entry into or work in or on confined or enclosed spaces may cause fires, explosions, injury, illness, or death. Because of these hazards, the Occupational Safety and Health Administration, or OSHA, as well as the Code of Federal Regulations, National Institute for Occupational Safety and Health, National Fire Protection Association, and the Coast Guard, has prepared regulations and guidelines for entry or work in or on confined and enclosed spaces. All shipboard personnel must be aware of the dangers of these spaces so they can recognize, evaluate, and correct or control hazardous situations. Personnel entering or working on or inside confined or enclosed spaces may encounter hazards including lack of oxygen to support life, excessive levels of oxygen which increase the danger of fire or explosions, presence of flammable, explosive, or toxic atmospheres or materials. Many factors need to be evaluated before entering a confined space or working around one. Such evaluations include researching whether present or previous contents of introduced flammables, toxicants, or oxygen-depleting or enriching agents. For example, spaces containing organic materials such as fruits, vegetables, natural fiber lines, or standing seawater will potentially deplete the oxygen and may further deteriorate into hydrogen sulfide or potentially methane. Rust is a good indicator of potential oxygen deficiencies and hydrogen gas buildup. Spaces which have been painted and immediately closed, or freshly painted spaces, can cause oxygen deficiency, carbon monoxide hazards, and toxic vapors. Another factor to be researched is the location and configuration of the space, including restricted access, obstructions, and remoteness. These factors may inhibit or interfere with movement, ventilation, escape, rescue, or firefighting efforts. Fixed equipment within the space, such as piping systems, conduits, ducts, machinery, or pressurized lines, are also potential hazards. It is important not to overlook other hazards, such as slippery surfaces, restricted walkways or ladders, or poor illumination which may be present inside shipboard spaces. Always make sure to use a safety checklist and notify the bridge and the engine room before any entry into or exit from an enclosed or confined space. All persons entering a confined space must wear personal protective equipment, or PPE, appropriate to the operation and exposure. When working with irritants, caustic or toxic materials, protective coveralls, gloves, and boots must be worn. In addition, clothing should be changed daily when in a cleaning process and handling sludge or similar products. Clothes should be changed immediately when saturated with irritant, caustic, or toxic materials. It is also imperative to change clothing and wash hands before eating, drinking, or smoking. Respiratory protection is crucial when working in hazardous atmospheres. Only approved respiratory protection shall be used, and such equipment should only be utilized for the purpose and exposures for which the equipment has been tested and approved. All exposures or potential exposures must be carefully evaluated before proper respiratory protective devices can be selected. This evaluation should include determining the types of contaminants present or likely to be present or generated, such as mists, fumes, or vapors. The concentrations of the contaminants and the appropriate exposure limits of the contaminants, including the threshold limit value, TLV, the permissible exposure limits, PEL, and the threshold limit value ceiling, TLVC, as well as the oxygen level, must be determined. The correct approved respiratory protection should then be selected. Respiratory protection is provided by self-contained breathing apparatuses, SCBAs, which may be closed circuit, open circuit demand, or open pressure demand. SCBAs are tested and approved for entry into or escape from atmospheres that are immediately dangerous to life or health. IDLH. Supplied air respirators include hose masks with and without blowers, and airline respirators with respirable air supplied from a compressor or cylinder. These types of apparatuses are only approved for non-IDLH. Gas masks with canisters that remove specific contaminants, such as ammonia from the indrawn air, are used for atmospheres that are not IDLH and that have enough oxygen to support life. Cartridge or filter-type respirators that remove contaminants such as dust, mist, fumes, or vapors are also only approved for non-IDLH atmospheres with sufficient oxygen. These types of devices are only capable of providing protection against specific contaminants in limited concentrations, as specified on the cartridge instructions. PPE should be maintained in good condition and cleaned daily after contact with irritants, caustic, or toxic materials. Because hazards are not always detectable by odor or sight, it is imperative to test for hazardous conditions prior to entering confined or enclosed spaces. All testing instruments must be properly calibrated and maintained as per the manufacturer's instructions before testing can begin. Initial testing shall be performed by drop tests or the insertion of sample probes or hoses. Next, test for combustible vapors or gases with approved combustible gas indicator. Concentration of 10% or greater of the LEL shall render the atmosphere IDLH. Next, test for oxygen content using an approved oxygen meter. The normal oxygen level of ambient air at sea level is 20.9%. Oxygen levels greater than 16.5% but less than 19.5% will be considered potentially dangerous. Oxygen levels less than 16.5% or greater than 22% shall be considered as IDLH. Then, test for toxics according to the nature of the space and its contents, use, or operations. Common toxicants aboard ship include hydrocarbons, hydrogen sulfide, carbon monoxide, carbon dioxide, and benzene. To maintain safe conditions, the atmosphere shall be periodically or continuously tested, especially during application of substances that may produce toxic or flammable vapors. Cleaning operations or any similar operations or conditions that may produce or release toxic, flammable, oxygen-enriched, or asphyxiating atmospheres. The objectives of ventilation are to capture and remove contaminants from the space and provide fresh, breathable air for health and general comfort. The three basic types of ventilation are general, dilution, and local exhaust ventilation. Depending upon the nature of the space, the contents, and the operations to be conducted within the space, one of these types or a combination of ventilation methods will be used. General ventilation is used to provide uncontaminated air for breathing and maintaining general comfort of personnel. The accepted practice of general ventilation is one complete air change every 3 minutes. Local exhaust ventilation systems contain an exhaust blower intake, positioned near the work which generates the contaminants. The contaminants are captured as they are generated and removed. This type of ventilation is most effective for removing contaminants generated from welding or localized solvent cleaning. Dilution ventilation is portable, locally rigged exhaust ventilation. By drawing air out of the space and replacing the stagnant air with fresh air drawn in by natural air circulation, the contaminated air within the space may be diluted to a safe level. Fans, blowers, motors, and other such equipment utilized to ventilate atmospheres containing flammable or explosive vapors, fumes, mists, or dusts shall be approved explosion-proof equipment, such as jet air movers or steam eductors. Equipment shall be bonded and grounded to control static electricity accumulation and discharges. The placement of exhaust duct inlets and make-up air inlets is extremely important to achieve proper air distribution. Air distribution and circulation will be improved when air entry and exhaust are accomplished through separate openings. When only one opening to the space is available, air circulation can be improved by extending a duct to the exhaust inlet from the bottom or back of the space. Always vent exhaust outlets carrying flammables or toxicants to the outside atmosphere where contaminants can disperse. Make sure not to place these outlets where they might contaminate adjacent spaces, accumulate, or expose personnel to the contaminated air. Inerting a space involves replacing oxygen or vapor mixture in the space with inert or non-flammable gas so that the resulting atmosphere will not support combustion. When personnel are entering and working in confined or enclosed spaces, rescue plans and procedures must be adapted. An emergency and rescue control point shall be set up to provide quick emergency rescue assistance, medical services, and treatment. This rescue control point should be located immediately adjacent to the space, and suitable communication methods shall be established. Emergency and rescue control points must be manned with an adequate number of trained and qualified personnel to enable rescue operations. Rescue personnel who enter a space to perform a rescue shall be equipped with approved pressure demand self-contained breathing apparatuses or a positive pressure airline hose mask with non-collapsible breathing hose and manual hand crank backup, equipped with a self-contained escape breathing device. They should also have a harness and a lifeline as well as other personal protective equipment applicable to the conditions. The ability to recognize hazards and safety precautions for confined and enclosed spaces is imperative for all ship's crew members. This video should be supplemented with proper training aboard ship and written vessel-specific procedures to ensure personnel safety while on board.